Hi, good morning everyone. For the meantime, we'll be doing the lecture here in this series of videos. I'll be uploading this sa YouTube para ma-access nyo anytime. You can download this or share it to anyone naman, to your classmates I hope. And then for the examples and the requirements of the course, tingnan ko pa kung paano yung magiging mode of delivery natin. Okay? So for the lectures, I'll be explaining yung laman ng slides. Through these videos, you have the access on the slides sa Edmodo. They are all in PDF form. Okay. So I think, yeah, I think I'll start. Okay, so our topic for this video is about DC generators. I'll be introducing yung DC generator sa inyo. What I have here is the definition of the DC generators. Paano ba tayo nagko-convert ng mechanical energy to electrical energy, and then what is a prime mover, and then yung power losses natin, power flow, etc. Okay, so as we all know, as I have discussed before, DC generators converts mechanical energy to electrical energy. So your mechanical energy is the input of your machine through mechanical torque and RPM as shown in this figure dun sa right side, and then you get the electrical energy dun sa terminals, dun sa i-induce. Okay, sorry. Okay, so this is an electromechanical induction process na na-discuss na natin from your first two chapters, yung ating linear DC machine and your rotational DC machine. Now we have a prime mover as the source of your mechanical energy, and usually ang ating prime movers are what do I have here? Turbines. So you have steam turbines and water turbines. Sometimes meron din tayong diesel engine. Okay. Now, in terms of power flow, you have the mechanical input as the input ng ating generator, and then the output would be your electrical energy. So your mechanical energy is in the form of tau omega, as you can see in the figure. And then on the output side, the electrical energy, you have the voltage and the current na makukuha mo sa terminals. That's basically the voltage at the terminals and the current at the line. Now from your mechanical energy to your electrical energy, you have the following power losses. You have the, what's this? The input energy, the mechanical energy, and then ignore muna natin stray losses, and then after the mechanical energy, you deduce the mechanical losses and the core losses. After those two, andun ka na ngayon sa P-convert. Now P-convert is equivalent to your P-develop at some literature. The idea of P-convert is yun yung point where the electrical energy is directly translatable to mechanical energy through tau omega equals E times I. So I have discussed this before in the lecture. Yung formula na yan, we've been using that. Now, your P input is not easily convertible to your electrical output because you have the losses. You have the following losses na naka-describe dyan. Okay. So after removing the mechanical and the core losses, wag muna nating intindihin yung stray losses. You have the P-convert, and the P-convert is the one na pwede mo i-convert yung mechanical tau omega into electrical voltage and current. Now P-convert is not yet P-output. Okay, hindi pa yan yung makukuha mong electrical energy. The electrical energy na makukuha mo from the P-convert ay babawasan mo pa ng I squared R losses, your copper losses. Basically those are the losses in the armature. Hello po. Those are the losses in the armature. Saan pa ba? You have the field. Yes. Okay. In some cases, but we'll go to that later. Okay. Now yeah, okay, sige. Now you have the following definitions. You have the mechanical losses. This is yung discussed ko before. Mechanical losses are basically due to your friction and windage. That's about 10 to 20% of the machine full load losses. And then you have the core losses. Basically, it's because of the hysteresis and eddy current loss. Na-discuss ko yung hysteresis and eddy current loss on your chapter 1. That's chapter 1. Okay, and dyan yung formula ng hysteresis and eddy current loss. It's about 20 to 30% ng machine full load losses. That's the total core loss. And then you have the copper losses. So your copper losses can be subdivided into your armature and field. Yan yung pinakamalaking loss ng rotating machine. So the idea is, if you have a generator that is rated at, let's say, I don't know, maybe 100 watts, or maybe 1 kilowatt 1 kilowatt na generator, if the output of the generator is 1 kilowatt, then you have to have an input of greater than 1 kilowatt because of the losses. Now, your brush losses are also categorized as electrical losses kasi they are because of the voltage drop at the brushes. Okay, so usually your voltage drop at the brushes is 2 volts total voltage drop for the carbon brush, and we have a more efficient one, yung ating metal graphite brush na 0.5 volts lang ang voltage drop. Now, if you have accounted for all of the losses, and then meron pang losses na nawawala, okay, let's say you have you have a machine na mayroong 10 kilowatts yung output, 11 kilowatts yung input, and then accounting all of the losses, ang na-compute mo lang na loss ay let's say 0.8 kilowatts. So yung hindi mo ma-account, we call that stray losses. Okay, it does not fall under mechanical, electrical, and core loss. Basically, hindi natin alam kung nasan siya. Para siyang ganun. Okay, now if we talk about the efficiency of the machine, we have 3 efficiencies. You have the electrical efficiency. It's basically an easy way to think about this is the electrical efficiency is yung efficiency mo due to your electrical losses. So yung electrical losses mo nawawala lang naman yan after the P convert. So that's why your electrical efficiency is P out over P convert. Now your mechanical efficiency is something that is your efficiency due to your mechanical losses. Okay, so nawawala yon at the beginning before the P convert naman. So that is P convert over P input. As you can see, your efficiency is always P out over P in. Nagbabago lang siya ng out or in, depende kung siya electrical or mechanical. We also have the commercial efficiency, your total efficiency. That is your P out over P in. Yun na yun. Okay? So, of course, all of them are times 100% para naka-percentage ang ating efficiency. For the voltage regulation, this is your performance, what do you call this? This is how you measure, this is how you measure the performance of your generator. Okay, this is how you measure the performance of your generator. You have the voltage regulation, which is basically ano ba yung voltage niya at no load versus ano yung voltage niya at full load. Okay, divided by voltage at full load. Okay, so you'll see the differences in the voltages kapag binabago mo kasi yung loading. Okay, we'll look into that in the examples later on, but yung voltages kasi ng generator nagbabago siya depende sa loading, and by loading ibig sabihin depende rin sa P out. Okay, so kung mabago yung loading ng machine, magbabago rin yung voltage at the terminals. We have the field excitation. This is the excitation ng ating magnetic field, because in this case for the following topics pa within this chapter ng DC generators. Medyo maingay dito. For the following chapters pa ng ating DC generators, wait lang. Okay. We'll be talking about, we'll be dealing with electromagnets, hindi na permanent magnets. Okay, so yung ating magnetic field ay manggagaling na sa ating electromagnets. So there are connections ng DC generators na nakadepende yung excitation ng field dun sa voltage dun sa terminal natin, or yeah, okay. I'll talk about that later on pa. Okay. This is used on larger machines usually, kasi in larger machines hindi practical gumamit ng permanent magnets. Mabigat siya, and mas madali makakuha ng mas malakas na magnetic field kung electromagnet ka when it comes to your larger machines. Okay. Excitation is the process of utilizing an electric current through the field coils to produce a magnetic field. So basically the idea here is you have a separate coil, another coil that is not an armature, that is not a part of the armature, and then yung coil na yon ay pwedeng may separate na voltage source. Pwede rin yung voltage source niya ay dun sa terminals ng generator itself, pero I guess ang pinakamadali ay may separation source, and then you excite that field through that source. So maglalagay ka sa kanya ng current, and then dahil dun sa current na nagpo-flow dun sa coil, meron kang may induce na magnetic field. So that's called excitation. Okay. So this is your equivalent circuit for what's this? A DC generator. So this is a separately excited DC generator. As you can see, you have the field coil separate from the DC generator armature coil itself. Okay, so you have two terminals here. Yung terminals na VT dito sa side na to, which one? This one. On the right side. Diyan yung output terminals ng generator. Now the field coils terminals dun sa VF natin, okay, dyan basically nilalagay yung DC source mo para magkaroon ka ng excitation ng field dun. So magkakaroon ka ng voltage dun dahil sa source mo, and then you have a current flowing through that coil, and then that coil produces a magnetic field na gagamitin nung right side coil para makapag-produce ng voltage. Okay? So if you look at the direction of the currents, ito yung pinaka-importante dito. If you look at the direction of the currents, yung sa field coil, you have the direction of the current going through the coil kasi nga sinusuplayan ng voltage source yung coil mo to produce a magnetic field. Now, dun sa armature side, because this is a generator, what you're actually producing is yung current mo, yung electrical current mo. Okay, that's why it's going out of the terminals and you have the voltage terminal. So sir, saan po rito yung input ng ating generator? As you can see, you have the EA, that is basically the induced voltage at the armature. The induced voltage at the armature, dyan nagkakaroon ng P-convert. Okay, so as you can see, you have the P-convert at the EA side, and then you subtract the losses dun sa armature, and then you get the P out. Okay, now on the EA, and dun yung P convert. So before the P convert, you have the mechanical losses, you have the core losses, you have the core losses, and then you have the mechanical losses. Yes. Okay, and then andun din yung P in. So it's basically, the P in is basically your power at EA plus your mechanical losses, plus your core losses, plus stray losses, kung may stray losses man tayo i-consider. Okay? So, here's the formula for EA. Itong, I'm not sure kung, wait. Okay. Okay, so here is the formula for EA. Basically, nanggaling lang siya dito sa iyong i-induced equals VBL. Now, if you look at the formula, you have the velocity na nandito sa R omega na to. You have the length. Okay, still, andyan pa rin yung length. And you have the magnetic field. Sorry. Yeah, you have the magnetic field phi and A. So, meron pa tayong mga hindi na account. You have the Z and the parallel path. Oh sir, bakit merong Z and merong A, small a? That is the parallel path. If you still remember this formula, this E-induced formula, this is the E-induced per conductor. So, for the whole armature, your whole armature kasi is composed of a set of conductors that are connected in series and in parallel, depende sa parallel paths. Okay, so that's why you have to multiply it by the number of conductors per parallel path. Okay, hindi siya pwedeng to the total number of conductors lang kasi hindi naman lahat ng conductors na yun ay nakaseries. So you have to consider na yung total number of conductors na yun ay divided equally on, well, ideally it's divided equally on the number of parallel paths. If you can still remember kung paano nyo ginagawa yung parallel paths on the, what's that? On the sorry, wait lang. On the laboratory, yes. Okay. So for the area